Welcome to This Explainer. Today, we're diving into one of the most mind-bending engineering paradoxes in human history. We're so used to assuming that modern tech is always better, right? But then, how do we explain the fact that ancient Roman structures are standing perfectly fine after thousands of years, while our modern infrastructure often starts crumbling in just a few decades? Well, stick around because the answer isn't magic, it's actually some absolutely brilliant, forgotten chemistry.
So, let's jump right in and frame our central mystery. Just imagine a building material that, when it gets damaged, can literally heal its own wounds. I know, it sounds like something straight out of a top-secret modern lab or a sci-fi movie, doesn't it? But what if I told you this self-repairing material wasn't from the future, but actually existed nearly 2,000 years ago in the Roman Empire?
Think about the incredible contrast here. On one hand, you've got the Pantheon, with its massive unreinforced dome, and Roman harbors that have taken a brutal beating from saltwater and earthquakes for centuries. And on the other hand, we have modern overpasses and bridges that literally need major repairs after a measly 30 or 40 years. The real mystery isn't just how these Roman structures survived the fall of an entire empire, it's how on earth we managed to completely forget the recipe for this amazing concrete.
Section 1. The 2,000-Year Mystery. Let's move on to our first major clue in figuring out what the Romans were doing so differently.
For the longest time, scientists thought the entirely secret was just volcanic ash. You see, the Romans mined this specific ash near the Bay of Naples, mixed it with lime and water, and created this super strong binder called pozzolana. And yeah, that ingredient was absolutely crucial. The empire spent massive resources shipping it everywhere. But when scientists really zoomed in on ancient samples, they kept noticing this one weird detail that just didn't sit right. The ash alone couldn't explain the material's strange internal structure.
It's actually wild how long science can get something wrong. For decades, modern engineers would look at these tiny, white chunks of lime scattered throughout literally every sample of ancient concrete and just say, oh, that's just a defect. The Romans didn't mix it well. Just lazy quality control. They completely wrote them off as ancient mistakes.
But let's put on our detective hats for a second. Put yourself in the shoes of a master builder in the Roman Empire. You're constructing aqueducts to supply water to 1 million people, building domes that defy gravity. Are you really going to tolerate sloppy mixing? Obviously not. These little white chunks couldn't be mistakes. They had to be there on purpose.
Section 2. The hot mixing breakthrough. Modern researchers at MIT refused to buy into this lazy builder theory either, and that skepticism led to a massive breakthrough. The real game changer here is that the Romans were using a completely different chemical process. Instead of using lime that was already mixed with water, they threw dry quicklime straight into the concrete mix. This triggered a violent, super high heat chemical reaction, a process appropriately called hot mixing. The temperature would just skyrocket, and because of that extreme heat, these highly reactive lime particles formed and got permanently trapped inside the concrete.
So, what we arrogantly thought was just sloppy manufacturing turned out to be a stroke of engineering genius. These tiny white chunks weren't flaws at all. They were microscopic chemical medics, just lying dormant inside the walls, waiting to be deployed. Section 3. Chemistry of Self-Healing. Now we're getting to the absolute core of our explainer. We're going to focus heavily on the actual chemical processes that give this ancient concrete its superpower, the exact moment it touches water. Buckle up, because this is where the real science happens. Let's shrink down to the microscopic level and watch this chemical drama unfold. Imagine a tiny microscopic crack forms in the concrete. Water starts seeping in. Now for modern concrete, this is the beginning of the end. But here, water is the trigger. The intruding water hits one of those dormant lime clasts we talked about. The quicklime instantly reacts, dissolving and creating this highly reactive, calcium-rich solution. Then, this solution floods the crack and rapidly crystallizes into solid calcium carbonate. Put simply, the concrete is literally growing new stone inside itself to stitch up its own wound. To actually prove this chemistry works, researchers recreated this hot mixing process in a lab, purposely cracked the samples, and ran water right through them. The results were absolutely mind-blowing. By day 7, the quicklime was reacting and calcium crystallization was in full swing. And after just 2 weeks, the crack was completely chemically healed. The water flow just stopped entirely. The concrete had healed itself. Meanwhile, the control samples without quicklime just stayed broken, exactly as you'd expect.
When you put them side by side, the contrast is just staggering. In our modern concrete, water is a deadly enemy. It gets in, freezes,
thaws, rusts the steel reinforcement, and literally tears the structure apart from the inside. But Roman concrete? It uses the exact same water that should destroy it as the fuel for its own survival. Water becomes the delivery mechanism that transports the building materials right to the site of the damage. It is an absolutely brilliant chemical synergy.
Section 4. A lost ancient system. If this chemistry is so incredibly effective, we have to ask the obvious question. How on earth did humanity lose this knowledge?
Well, it comes down to a totally different philosophy of building. The modern industry prioritizes speed, cheap costs, and absolute uniformity. Roman engineering, though, was playing a different game. Their priority was endurance. They weren't designing a material to just passively sit there and resist the elements. They designed it to actively, chemically interact with its environment over centuries.
But here's the thing. Technology doesn't exist in a vacuum. The Roman recipe required massive logistics, specific volcanic ash, highly skilled builders, and incredibly organized labor. When the Western Roman Empire collapsed, those massive supply chains shattered. The specific knowledge of hot mixing just scattered and faded away. Medieval builders pivoted back to stone and timber. And eventually, the industrial age made its choice.
Modern Portland cement took over the world, but it didn't win because it could last forever. It won the race because it was absolutely perfect for mass production. We basically traded eternal chemical endurance for the convenience of making massive amounts of uniform cement anywhere incredibly fast.
Section 5. The Future of Concrete. Let's look at why recovering this lost chemistry could literally save our world today.
Concrete is literally the most used material on the planet after water. And manufacturing standard cement leaves a massive carbon footprint, driving a huge share of global CO2 emissions. Our infrastructure keeps cracking, we tear it down, make new cements, and rebuild it. It's a vicious cycle. If we can integrate this ancient self-repairing principle into modern materials, we could drastically cut down the environmental toll of constantly replacing failing buildings.
Now, scientists aren't saying we should drop everything and start building aqueducts out of volcanic ash again. That's not the point. The goal is to recover the principle. We need to stop fearing water and start designing smart, modern materials where these chemical reactions are baked in from the start, so our structures can actively maintain themselves for decades.
I absolutely love this quote. It was not just strong, it was alive in a chemical sense. It really forces you to rethink history. Ancient tech wasn't primitive at all. It was just optimized for a civilization that planned in centuries, not just for the next fiscal quarter. I'm going to leave you with this final thought. Next time you see a crack in a modern concrete wall, think about the Romans. Has one of the greatest secrets to a sustainable future really been hiding inside ancient ruins this whole time? Sometimes we don't need to invent things from scratch. We just need to look a little closer at the past. Thanks for joining me on this explainer, and I'll see you next time.